Thank you.
This call is now being recorded.
On behalf of IGNO Regional Center Bhubaneswar, I welcome you all to this online class. This is on your post-graduate diploma in analytical chemistry program, and I am assigned to cover your second theory paper. That is MCH-02 paper, and from last 2 days we have discussed the different separation techniques, different separation methods, which involve the physical aspects as well as the solvent extraction process. In the past day, we have covered the basic of your separation methods. It includes your filtration, distillation, fractional distillation, electromigration, then followed by solvent extraction 1, solvent extraction 2. So yesterday we have discussed the mainly the liquid chromatography. In the first part is the basic of chromatography, and that is what is meant by stationary page, what is mobile page, followed by the type of stationary page and mobile page used based on the different components present in a mixture, and based on this informative data, we have classified the liquid chromatography into two types: the liquid solid chromatography and liquid chromatography. And in liquid solid chromatography, as you all know, the liquid phase is treated as the mobile phase, whereas the solid is treated as the stationary phase. The mechanism involved in liquid solid chromatography is the mechanism of adsorption, where solid phase is acts as the adsorbent, whereas the liquid phase or mobile phase particles are treated as the adsorbent, on which different particles of the component gets adsorbed, and parallelly we discuss some mm, your retention factor or the migration factors and the distribution coefficient, distribution factor, distribution velocity. So these parameters are already discussed, and today we have a new unit, which is unit number 6, which is based on pure paper chromatography or planar chromatography. So before this, I'll just share my screen with you. Is it visible, students? Paper chromatography means it is your chromatography. So is it visible? Anyone please respond?
Yes, sir, visible.
Okay, thank you. So this is a PDF, which is based. Sorry, this is a PPT PowerPoint presentation based on the chromatographic separation technique. So he is Michael Sweat, who introduced the whole world about the concept of chromatography in the year 1906. So, as we know, one small positive thought in the morning can change your whole entire day. So, likewise, this concept, that is the chromatography concept, the chromatography in chromatography, the first word is chroma, which means color, and a graphy means it is a writing. So that's it. Uh, So chromatography related to some color components or color pigments from your samples. So Michael Swade named this technique as chromatography, that is separation is based on color. So it is a separation technique based on the different interaction of compounds with two phases, as we already knew that one is known as the mobile phase and the second is known as the static phase or stationary phase. As the compound travels through a support. So what is mobile phase? A solvent that flows through the supporting medium, that is the stationary phase, and the stationary phase, which is a layer or a coating on the supporting medium that interact with the analytes or compounds. So what is supporting medium? A solid surface on which the stationary phase is bound or coated. So there are mainly two phases, mobile phase and stationary phase. And this is the chromatography, as we already know that Michael Sweat, he discovered the concept of your chromatography in 1903 when the plant pigment testing of your chlorophyll, xanthophyls and carotenoids separated on a chalk calcium carbonate color by PET ether. So in 1931, linear chromatography or your liquid chromatography was introduced. 1958, thin layer chromatography and ion exchange chromatography. In 1950, we have reverse phase liquid chromatography. And in 1954, the study that was carried out by Martin and Sims in 1954, and they have got the Nobel Prize. So 1959, gel permeation chromatography, that is your site extruder chromatography (SEC), and your instrumental liquid chromatography. Instrumental liquid chromatography. Just words there. Sorry for the inconvenience, students. So let's move on. So in 1937 to 1972, 12 Nobel Prizes were awarded based on chromatography. So this is a very popular and experimental as well as the researchable technique of separation. So the purpose and advantages. Your separation and detection of component from colored, colorless, simple and mixture of samples, purification and collection. This is the main purpose or aim of this technique. And what are the advantages? The chemically similar and physically closely resemble samples can be separated. Separation is due to difference in physical properties at room temperature or below. Sensitive micro and picogram sample can be separated and detected. That is versatile technique. So it is a versatile technique in which microgram or picogram 10 to the minus 12 gram samples can be separated and detected. It's a very simple, rapid and elegant method. So complex mixture can be separated and detected. Simple and inexpensive equipment. So this is also one of the major advantages of this instrument, that is very simple and inexpensive technique. So this is the primary principle of your chromatography. As we know, component of the mixture subject to two opposing forces, one by stationary, other by mobile. So there are two forces now act on the different component in the mixture. That is the force from the stationary as well as the force from the mobile phase. So this is a just a tutorial form. Just see here we have a mixture of different components. So as we know, this is the mobile phase, that is the orange color, and your blue color is the stationary phase. Okay. So mixture is placed in a system. The mixture is placed in the column or in the paper or in the thin layer, chromatography thin layer. Mobile phase percolates through interstitices or an on the stationary phase. That means interstitices means it is the void of the intermolecular space available in the stationary phase, with the components first percolates through these interstitices or voids. So mobile phase exerts driving force on solutes of mixtures and tends to carry them along with itself into solvation power. So next, so different components are moving by the mobile phase of the solvent chosen through their solvation power. Simultaneously, stationary phase tends to retain solutes by them due to absorption power. So two types of things are there. The solvation power will uh, will the different components to pass through or percolate through the stationary phase, and the stationary phase has the power of absorption by which it try to stop the flow of components to it. So there are two opposing forces. One try to percolate and one try to stop. So simultaneously, your stationary phase having that absorption power, so but the extent of these two forces are different. Therefore, component distribute between stationary and mobile phase. This is very well explained. That is the due to difference in their solvation and absorption power, the different components gets adhere or gets adsorbed on the surface of adsorbent, that is the stationary phase, to different extent. So by which we can calculate the distribution coefficient as well as the retention factor. So the distribution coefficient, as we already know, that distribution coefficient is the K, that is the concentration of solute in stationary divided by concentration of solute in mobile phase. So higher is the value of K, that means greater is the opposing force, that is the stationary phase is as the it is at the numerator. So that's why when the value of K is more, that means concentration of solute of in stationary phase is more. That means it will have the greater opposing force and lesser movement of the component and vice versa. So this is how different components in a mixture when passed through stationary phase along with the mobile phase, then according to their extent of adsorption or extent of interaction in the stationary phase, the components gets separated. This is how, like this is a Olympic race in which Usain Bolt stands fast because he populates or he passed all the his contemporary or competitors behind. Okay. So classification of chromatography. So chromatography is classified based on the operating process. Like if it is adsorption, that is surface active, that is the stationary phase is solid. If it is partition, then this is distribution, stationary phase is liquid. If it is ion exchange, it is ion exchange chromatography. If it is the force is affinity, that means ligand attractive force is there. If it is formation, then it is size exclusion chromatography or molecular sealing chromatography, in which cages are there to which small pores will be there, and according to their size, a small particle will populate first, followed by the big size particles. So this is a small classification, that is chromatography. It is your gas chromatography, HCFC or liquid chromatography. Okay, this is your GSC or GLC. We have, that is your gas solid chromatography or gas liquid chromatography, and here HCFC we have normal phase chromatography and reverse phase chromatography, where your in liquid chromatography we have planar, that is your two-dimensional chromatography, the thin layer and paper, and in three dimension we have column. Then under column we have liquid solid chromatography, it is ion exchange chromatography, side exclusion chromatography, liquid chromatography, and side exclusion is again of two types. For organic compound it is gas GPC or GFC. And in latter part, we will know the full form of this new type of chromatography. Okay. And one type is your HPLC, which is about high performance liquid chromatography. HCFC is HCFC chromatography. This is your supercritical filter. Yes. This is yesterday we have discussed supercritical fluid chromatography. This is another form of your liquid chromatography. Then we have your what is this? BPC. What is BPC? Have BPC. Base peak chromatography. So here is some peak or signal will be obtained by different chromatographic methods, and generally the liquid chromatography mass spectrometry will have this type of chromatogram, that is base peak chromatogram. Then we have GPC. What is GPC? Let's have a full form here. That is your gel formation chromatography. Yes, this is gel formation chromatography. And GFC, it is your gel filtration chromatography. Yes, so we have all the full form of different chromatography techniques. You see here gas chromatography, gas solid chromatography, and gas liquid chromatography. This is your supercritical fluid chromatography. If the stationary phase is polar, then it is normal phase chromatography, and if the stationary phase is less polar or non-polar, it is reverse phase chromatography. Under liquid chromatography, we have three-dimensional and two-dimensional. The three-dimensional includes the column chromatography, and the two-dimensional includes the Thin layer chromatography and paper chromatography, which we will discuss today. Then we have under column, we have liquid solid chromatography, ion exchange chromatography, size exclusion chromatography, liquid liquid chromatography, base peak chromatography, high performance liquid chromatography, gel permeation chromatography, and gel filtration chromatography. So all these are uh, different chromatographies based on their type of process, type of solid, stationary and mobile phase applied or used. So here is a very good quote, दुनिया में कोई काम इम्पॉसिबल नहीं, बस हौसला और मेहनत की जरूरत है। इम्पॉसिबल को गौर से देखो, वो खुद कहता है आई एम पॉसिबल. So paper chromatography, which is the today's discussion, just see here, students. This is your unit 6, that is your standard chromatography, which includes your paper chromatography. Okay, so this paper chromatography we will discuss in this PowerPoint presentation. So paper chromatography, it is a paper on which the separation is carried out, and it is a type of liquid chromatography. Paper provides mechanical support, which is the supporting material to the stationary page. The compound partitioning itself between two liquid phases, stationary phase, paper absorbs and hold water, mobile phase non aqueous. So there are two phases, that is the stationary phase and the mobile phase, in which the paper acts as the supporting medium and water will absorb by the paper, and which is acts as the stationary phase, and the mobile phase is all about your solvent. So mobile phase travel along the paper. The components of loaded mixture distribute themselves between two phases in a ratio. Characteristics of their distribution coefficient. Components more soluble in stationary phase move slowly. Components more soluble in mobile phase move faster in mobile phase. As a result, different movements they get distributed. So distribution coefficient K dash equal to concentration of solute in stationary phase divided by concentration of solute in mobile phase. So this is the interaction of different components with two different phases. If the component is more interacted or more soluble in stationary phase, then it will move slowly. If it moves slowly, then separation will be delayed. But the component which is more soluble in stationary phase will move slowly and separated at the end or at last. The component which is soluble in mobile phase will move faster, and they will separated first. So, so this is the way what happen. Different components get separated based on their interaction with the solid and liquid phase. That is the stationary and mobile phase. As we know, distribution concentration of solute in stationary phase, also solute in mobile phase. The solute is not other than your different components. Only those compounds which differ in their K value under the given set of conditions are separated. Yes, this is very important, because when the distribution coefficient value of different components are different, then only we can say the components are separated. If the value becomes same, then there will be no separation. The mixture remain as such. So important aspect of paper chromatography, the quality of separation and purity of sample depends on filter paper. That is a paper we have used as the supporting medium. Different turning characters, slow, medium, and fast. Stationary phase, cellulose fiber of paper absorb. Cellulose fibers of paper absorb water and hold it strongly. Water content is 115 to 195%. Aqueous phase is held so strongly that under normal condition it is impossible to move. So there are these are some examples where filter paper is used as the medium, that is the supporting medium, and stationary phase is organic solvent, and mobile phase the water. For filter paper, if it is workman 1, then according to the grain size or the pore size, the supporting medium is accordingly used. And for your solvent system, that is the mobile phase, we have different solvents prepared with water. For several organic solvents incorporate very small amount of water. The polar components of mixture fails to separate them in such binary system. For example, hydrochloric acid, acetic acid, formic acid, ammonia, pyridine, and complexing agents are used. It helps to retain more water in organic solvents. Generally, three component system is used. Then your spraying agent, reagent. To locate colorless components by spraying reagent, the reagent react with component and develop color in region where they are present. So these are some important aspects of your paper chromatography, which is a planar chromatography. So commonly used solvents, just see here, your compound is amino acid, solvent is butanol, pyridine, water in equal ratio, or methanol, pyridine, water in 25 is to 3 is to 63, that means 1 is to 2 is to 4 ratio. And phenol water, if it is 8 is to 2 ratio, then here the spraying reagent is neem hydrin. Similarly, we have the carbohydrate separation, where butanol, acetic acid, water, 2-propanol, pyridine, water, acetic acid in this ratio can be used as the mobile phase of the solvent system, and here are the spraying reagents. So chlorophyll, propanol is used, the metal ions, ethylene, and hydrochloric acid in 9 is to 1 ratio it may be used. But this is the important aspect, that is the methodology part. So how your paper chromatography works. So first you take the paper chromatography paper, then from the bottom you mark it to after a distance of 2 centimeter, mark a line, and this line is now treated as a reference line. And you put your sample spot here with the help of a dropper or a glass tube. Okay. Then after this, we will just see here. We will have a chromatogram chamber. It's just a small beaker or a glass box you have. So this is known as a chromatogram. If you if you just put the paper inside the solvent, that is the appropriate solvent, then what happens? The solvent will blow up in the paper. At the same time, the sample containing different components will move according to their interaction with the solid stationary phase. So just see here, when the paper is dipped or it is poured inside the solvent, then what happens? The different component present inside the reference is now moving upward along with the solvent. Then gradually what happens? We have predicted, or we have seen, or we have observed four different spots on that paper chromatograph. So four spot means that mixture contain four components. You see here, I'm just zooming it. You see here, this is the sample. This is the mobile phase. This is known as the stationary phase. This is the paper is the stationary phase. And now the mobile phase is go up. The sample we have put at the reference line. It is now moved up, and gradually after few minutes we see that some spots are there which is visible under UV light or ordinary light after drying. So just see here, B is the total distance traveled by the mobile phase, and A is the distance traveled by the component 1. So what is the retention factor? Distance traveled by the component divided by distance traveled by the solvent. So distance traveled by the component is A, and distance traveled by the solvent is B. So the retention factor RF, it is said to be A by B. So this is known as the ascending paper chromatography, where the your what your components, different components are separated from bottom to top approach. So this is ascending. So when your chromatography paper is just hang with the help of a clip or some technical tools, then what happen? When at this position, the paper is deep inside the solvent chamber, then the solvent will beat the paper from the top point and it is moved downward. Then when the solvent reaches the reference point, then different components are now start separating depending upon their interaction with the stationary phase. So when the solvent is now moved from top to bottom, so this is known as the descending, top to bottom. So this is now top to bottom. It will reach at the reference point. The sample is there. Then different components get separated based on their interaction with the stationary phase. So the paper chromatography is of two types. That is the ascending and the descending. So this chamber is known as the your chromatogram. Hello, hello. हाँ सालू नमस्कार कुह प्रोजेक्ट पीडीएफ रहिबो सिनॉप्सिस रहिबो आई कार्ड रहिबो अप्रूवल लेटर सबरे सब कॉपी रहिबो हाँ 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 हम्म So let's continue our uh, this ascending and descending chromatography. So whenever your paper is dipped inside the solvent, where the solvent is at the bottom and the reference line is at the bottom, then it is said to be ascending chromatography, and different components get separated on the basis of their interaction with the stationary phase. And here, a very important thing, that is the retention factor is calculated by dividing the distance traveled by the component with the distance traveled by the solvent. Okay, and this is another, just see here, it is a size exclusion chromatography, where your small size particles are separated first, whereas the large size particles are separated at the end. And this is also depends on the polarity. That is the this is the polar end, this is the unpolar or non-polar end. So these things we will discuss in the size exclusion chromatography chapter. And this is known as the descending chromatography, in which the paper is hanged with the help of a clip or some technical tools, and uh, your top of the paper, the tip of the paper is now dipped inside the solvent, and the reference line is at the bottom. Then the solvent move through or pass through this chromatographic paper, and when the solvent reaches the reference point, then only the different components start separating, and it is known as the what is top to bottom approach. It is descending top to bottom. So here also the reference factor is accordingly calculated. Just here see the rate of flow. As we know, when a component is having strong interaction with the stationary phase, the rate of flow is slow and it will separated at the end. Whereas the component which has the uh, small interaction with the stationary phase, it will separated uh, very fast. Okay, so just see here, there is a component that is a D1. Sorry, this is a component here, and this is your reference sample, and we have a solvent front line here. Solvent front line means the maximum distance traveled by the solvent. It is known as solvent front line. So the RF of this component, it is said to be D1, that is the distance traveled by the component with respect to the reference line. 2, the distance traveled by the solvent with reference to the solvent line, a reference line to the solvent front line, that is D1 by D2. Similarly, there is a standard reference, and here also we have the same thing. Then rate of flow of RF is the distance traveled by solute divided by distance traveled by the solvent. So this solute is same as your component. Then in reference we have distance moved by the substance divided by distance moved by the standard. So this is the standard sample, or this is the solvent one, and this is the substance mean, this is the component. For this solute we have. So retention factor values of substances depends on quantity and dimension of paper. Yes, it is correct. That is the quality of the paper and dimension of the paper affects the value of RF. Solvent system, its flow rate, and direction of flow. If the direction is from bottom to top, it is said to be ascending, and if it is top to bottom, it is said to be descending. Temperature of the environment, size of chromatogram, developing vessel. This is known as chromatogram. When these factors constant, then it is possible to compare retention factor value of unknown and unknown, known and unknown. So application of paper chromatography, that is separation of amino acids, peptides, alkaloids, sugar, liquid, metal ions, etc. To limited extent, it can be used as preparatory method to study different structure of amino acids and composition of some proteins, analysis of blood, urine, hemoglobin, etc. So these are some examples of your paper chromatography or application of paper chromatography. So what is the advantages? This is very simple, inexpensive and sensitive technique. Now what are the disadvantages? Time taking, not suitable for preparative method. So for any preparation of a pure sample or for your research work, you may not use this as a preparative method because there may be contamination or mixing of the component with one another. Then again by Leo Tolstoy, the two most powerful warriors are patience and time. So column chromatography. So this is a three-dimensional chromatography. So before this, let's have a look at our PTF, that is unit 6. So this is in this part, planar chromatography, we have two chromatographies, that is your paper chromatography PC and thin layer chromatography PLC. And we have also one advanced chromatography which is known as high performance PLC, that is high performance thin layer chromatography. Then what are the quantitative as a comparison of PC with PLC, it is there. So let's have some discussion here. As we know, in paper chromatography, we have a paper which is used as the supporting medium, and where your water is soaked on the paper, and your chosen solvent, which is suitable to separate the different components, is treated as the mobile phase. Then we have the quantitative and qualitative aspect of this planar chromatography. Then the very important parameter is the retardation or retention factor. Retention means how much time or how for a time period the different components are adhere or it is interacted with the stationary phase. Then we have some objective of this unit, that it explains the meaning of planar chromatography, principle of paper chromatography, meaning of RF, the retention factor, and factors affecting it, discuss the type of paper used as support or the mixture used in paper chromatography, describe how to run and develop the paper chromatogram, explain the methodology of separation involving organic mixtures, give the potential application of paper chromatography, describe the principle of PLC and its application, and your last one is your high performance linear chromatography. So in paper chromatography, as you already know, and for this technique in 1944, your R. Constein and Goran, the two co-workers of Martin, got Nobel Prize. Okay. And the principle is already discussed. There is a separation medium or stationary phase, and we have a chosen solvent as the mobile phase. And here the principle, that is the liquid-liquid partition or distribution of your liquid states will be there, and this is the retention factor, that is distance traveled by the solute. This is the component, solute means is the component divided by distance traveled by the solvent, that is ds by dm. So just remember RF value cannot exceed 1. So as 1 is the 100% your travel of the component, that means RF never exceed 1. Okay, because the maximum distance uh, traveled by only the solvent. And this is the way, and this is the reference line of the origin. This is the total distance traveled by the solvent, and this is the distance traveled by the solute or the component. So whenever you measure the distance, the measurement should be from your reference line. Okay. So from the reference line, the distance traveled by the component is x, distance traveled by the solvent is y. So retention factor will be x by y. So the different factors which hampers or which affect the paper chromatography is presence of ions, like presence of chlorides, uh, is carried out the nitrate solution, acidity of the original solution, then the development of time. Sometime it increases with the running time, therefore optimum time will be determined. Presence of other cations or anions as impurities, then ambient temperature. So these are some factors which affects the chromatography technique. Since the retention factor value depends on the distribution of complex of the cation with different organic solvents, solvents should be carefully chosen. Yes, this is very important. Whether you are trying to separate a complex ion or a simple ion or a covalent molecule or a organic molecule with some specific applications, then accordingly you should choose your solvent. Then it is your stationary support, that is the paper we have. So the paper may be Hartmann 1 to 31 or 3 or acetic acid paper having hydrophilic affinity for water. So after soaking of water in the paper, it is acts as a stationary. Okay. And sometimes some selecting agents like DMC, dimethyl glyoxy, 8-hydroxyquinoline, these are also used as the your uh, for making stationary pages. Then the paper chromatography, the paper show following properties. What are the properties? Weak ion exchange property. The paper should have weak ion exchange property and should have a good adsorption property, good water holding property, and mild reducing property. So these are some properties of a paper to be selected as stationary page for your paper chromatography. Then we have the mobile phase, there is a solvent system. So in this mobile phase, we have two types of solvents, that is polar and non-polar. If it is less polar, then the solvents like ethanol, acetone, glycol, formamide, acid and amines can be used. For polar solvent, we may use water, acts as the polar solvent. The basic criteria is the solvent should not react chemically with any of the component. This is number one. The composition of solvent mixture should not change with time. It means that none of its components should be volatile. The solvent should not interfere with the detection of spots. The distribution ratio should be independent of solute concentration. The minimum difference between retention factor value of any two component should be 0.5 or 0.1. Well, these are some basic criteria before choosing a solvent as the mobile phase. Some solvents commonly employed for the separation of cation are mentioned below. N-butanol, saturated with 3 molar hydrochloric acid is to equal volume of alcohol and acid are second together and upper layer is used. So these are some examples of the solvent which are frequently used in different chromatographic techniques, and it is primarily using in your paper chromatography. For development of chromatogram, it is a paper. The paper size must be 4 to 5 centimeter to 35 to centimeter, 40 centimeter length. This is the breadth we have. And then put a thin pencil line after 2 or 3 centimeter. Then like this. So this is 4 to 5 centimeter. This is 35 to 40 centimeter. And after 2 centimeter, 3 centimeter, draw a line which is known as the reference line, and just put different samples on the reference point, and with the help of a dryer just dry it. Then after drying, it is now put inside a beaker, small beaker, which is known as the chromatogram, and a watch glass is cover, and that beaker contains your chosen solvent, and that solvent is acts as the mobile page, and that paper with your sample as a reference line is treated as the stationary page. So gradually what? So this is the chamber we have, that is known as the chromatogram. So this is your descending chromatogram, and this is your ascending chromatogram. Ascending means your paper is deep inside the solvent, and your different components are moved from bottom to top direction. But here your paper is hanged like this. So this is in a hanging position. And now the paper is allowed to dip inside the solvent which is present inside the chromatogram, and gradually what happened, the paper is now soaking, sorry, the solvent is now soaked the paper from top direction to bottom. So this is your top to down or your descending paper chromatogram. Then we have the lateral diffusion of the solute, variation in structure, detection method, just try to detect under fluorescence light or UV light. Okay. Then the radioactive measurement of the radio pressures can be done. Electrochemical methods like potentiometry, conductometry calculation or measurement, sorry, polarography can be used. So this is an example of one experiment, that is a silver, lead and mercury. Both three are came out as different components within a mixture with a traveling distance of 15.8, 28.1 and 5.9, with a total distance traveled by the solvent is 18.4. Then what is the retention factor? For silver it is 15.8 by 18.4, for lead it is 12.1 by 18.4, for mercury it is 5.9 by 18.4. So this is here, these are the key values, and and here it is written that emission gases of two-wheeler were tested for polluted metal by people chromatography. The spot corresponds to RS 0.65 was observed. What is the possible pollutant? That is for the pollution detection of any vehicle. This chromatography experiment can be a huge or handy tool to detect what is the pollutant, which is what a major pollutant. If they are in the air pollution is supposed to be happening by the vehicle. When the gas is passed, it is see that the pollutant is RF of 0.65, and when we calculate all these ions, retention factor of all these ions, we get that lead is having the retention factor close to 0.65. That's why the major component is there for the pollution or regarded as a pollutant may be your lead plus. So this is how the cross checking of pollutants are done. Then we have the application identification of trace metal in ore, checking purity of pharmaceutical and fermentation, ripening of fruit and fermentation of products, detection of allergens and contaminants of food and drinks by comparing chromatogram of pure compound with that of the adulterated. So this is some example where different amino acids, that is histidine, lysine, arginine, proline, glycine, bromine, serine, alanine, vitamin, valine. So these are some your amino acids which are separated which by using two-dimensional paper chromatography of a protein hydrolyzed. Then in the same way, we have some examples, that is separation of manganese, nickel, cobalt, and zinc using retention factor values. Then we have separation of mixture of pesticides like your aldrin, nendrin, linden, that is heptachlor, DDT, dichlorodiphene, trichloroethane, and your benzene hexachloride, BHC, by using Hartmann 1 paper as the supporting medium, and your diethyl ether and acetone 75% and 5% ratio. It is used as the stationary phase in the way that your Hartmann paper, one paper is soaked with these two solvents, and then the mobile phase uses methanol water in the ratio 3, in the ratio 3 is to 1, and the different retention factors are came out like this 0.37, 0.48, and etc. Separation between anions of sulfur, that is sulfate, higher sulfate, and tetra, tetrahyosulfate, base 406, 2 minus. So accordingly, your solvent is chosen for your stationary phase and your mobile phase. Then autoradiography using radio tracers. So just read out these things because the, the radioactive elements are used, and how different isotope of carbon, phosphorus, your hydrogen gets trapped or gets highlighted with this use of chromatography. So this is how a leaf that is under the sunlight, it is emitting your carbon 14 carbon dioxide, which is radioactive, and under your chromatogram experiment, this can be easily obtained. So just see here a reference sample with three different spots like PQR with the solvent used, ethanol and water, and these are the distances traveled by the solute as well as the solvent. So this is about the paper chromatography. Then we have thin layer chromatography. So for thin layer chromatography, so before this, students, any doubt or anything you wish to ask, you may ask him. Jitendra or Farin, Vijayalakshmi. Okay. So if no question is there, so let's have some 5 minutes of break, and after that we will continue. Thank you, students. So next is thin layer chromatography.
Hello.
So like paper
Hello.
chromatography, yes,
Sir, can I ask you a question?
yes,
Uh, so ये first figure 5 figure 6.4 में
figure 6.4.
6.4 इसमें separation
Just wait, just wait.
of this
Yes, 6.4, this one, yes.
ये क्या separate by protein है क्या?
हाँ ये वाला है ना, ये जो दिया है, this is
हाँ
paper chromatography of protein.
protein. Okay, okay.
So this is
Thank you.
the different spot of your different amino acids present in protein.
Different types of protein.
Yes, yes, yes.
Okay.
So here your acetic acid and your butanol used as the stationary phase solvent, and the phenol with resorcinol and water used as the mobile phase solvent. Okay.
Okay, thank you, sir.
Okay. So next we have the next chromatography, that is thin layer chromatography, in which your this chromatography is different from your paper chromatography, where a flat surface of glass, metal, or plastic coated with adsorbent such as silica gel, alumina, or any other material is used. And this technique was discovered by this person, that is Ismailov and Steber, in 1938. So here also the same principle applies, which is your stationary phase and your mobile phase concept. The stationary phase, your stationary phase, it acts as the adsorbent on which the particles of your adsorbate, that is your different components, gets adsorbed, and the molecular C, it can serve as the support for a liquid film, and it consists of finely divided powder of 5 to 50 micrometer. A variety of stationary supports are available for coating smooth surface glass, etc. etc. It is already written that silica gel, it is a platform for your silica gel with different mesh size. So depending on your type of components you are aiming to separate. So silica gel is available in the market with different mesh size, and different mesh size like 60 to 120 mesh, your the 240 to 300 mesh. So depending on your mesh size, you can separate your different components. So in modified silica, it is written in modified silica, that is the advanced version of silica, hydrogen and OH group can be replaced by other functional groups similar to bonded phases. And the commercial name of these your stationary phases of different chemical compounds may be like your GOX 500W, when it is used for strong acid cation exchanges in sodium or hydrogen, or GOX 1, that is used as a strong base anion exchanger, etc. So this is commercially available in the market. So this is your apparatus used for preparing thin layer chromatography plate, where the applicator is filled with the slurry of adsorbent and binder in solvent. That means your silica gel with the different mesh size, it is now the water is added to it and make a slurry. Slurry means you can say it is just a hard liquid. Okay, or you can say that a dense liquid. It is the correct word. That is dense liquid. So the slurry is now uniformly spread over the chromatogram. This is the chromatogram we have, and the slurry is now spread uniformly. Then after the spreading of the slurry, then we have the We have the your sample as well as the mobile page movement. So just I read out these two lines that in layer of Cefadex superfine gel, this is the commercial name, can be prepared for size exclusion chromatography, where your different components are separated based on their dimension or size, particle size. Jet is soaked in water for a few days and then sprayed on the plate. So now the gel is soaked on water for a few days and then it is sprayed. That means for a few days, if this is under like your sunlight or your any hot plate, or sorry, it is your what is known as this oven, hot oven. So these are not dried but stored wet. Capillary action through this molecular sieve is much smaller, slower, typically from 1 to 2 centimeter per hour. So there is a precaution must be followed while handling PLC plate. The surface of the PLC plate should not be touched. The plate should be handled carefully by holding at the edge so as to avoid any contamination due to sweat. The plate should be cleaned thoroughly so as to remove any extraneous material that might contaminate the absorbent. So these are some precautionary steps which must be followed for the preparation of PLC plate. Similarly, the mobile page, the choice of mobile page is largely empirical, but some general guidelines are there. The developing solvent must be of the highest purity because when traces amount of impurity may yield reproducible results. Good separation of polar or ionic solutes can be achieved with a mixture of water and N-butanol. The criteria used for selection of developing solvent are the same as for column chromatography. The eluent, the eluting power of solvent increases in the order of their polarities. Example, hexane to acetone, 2 alcohol to water. That means it is non-polar to polar. Water is polar. So the heliotropic series, that is table 6.1, is given. You will see this is the heliotropic series or the solvent chain from your polarity. Okay. If the stationary phase is hydrophobic, that is it heats your water, mixture of benzene, cyclohexane, and chloroform, different ratio provided, satisfactory mobile phase. So depending on the type of component, type of stationary phase you have used, then accordingly your solvent is chosen from non-polar to polar. So the apparatus required, the PLC plates which are available in the market, that is of different dimensions, and depending upon your number of component and the type of component you have trying to separate, and accordingly you choose your plate size. The plate, the minimum size available is 2.5 centimeter into 10 centimeter, followed by 2.5 into 15 into 20, then 5 into 20, 10 into 20, and 20 into 20. So depending upon your requirement or your application, you choose the plates accordingly. There are two types. These are two types: conventional and high performance. So the former have thicker layer about 0.25 millimeter with a particle size of less than 20 micrometer. On the other hand, in high performance, the thickness is 0.1 millimeter. That means it is very thin, and the particle size is also less than 5 micrometer. So depending upon your particle size and your uh, type of stationary and mobile page used, you are advised to choose your plate size accordingly. Then this is the way, and like your paper chromatography, this is also known as the chromatogram. We have a glass chamber covered with a lid, and your thin TLC plate, that is the thin layer chromatography plate, which is acts as the stationary phase after the uniform spreading of the slurry of generally your silica gel of different mesh size. Then when the plate it is your now this plate on this your chromatography plate, that is the TLC, your reference your sample is dried, and after the sample then it is deep inside the solvent. Then what happened? This is your ascending, because this is bottom to top. Your different components gets adsorbed on the surface of the slurry of the stationary phase, depending on their interaction with the stationary phase. When we have the plate is immersed in the developing solvent, avoiding the direct contact, the developing solvent travels off the plate, and after passing through the point of the sample of application, it dissolves the sample and carries it off the plate, where the sample distributes itself between the moving solvent and stationary phase. After the developer has traveled about two-thirds of the length of the plate, it is removed from the container and dried. The position of the component are then determined by any of the method described in the next session. So when the developer or the components are traveled about two-thirds of the length of the plate, then it is removed from the container and it is dried under your oven. Then it is the measure the distance traveled by your component. The detection of the spot in TLC is easier than PC, as silica and aluminum is just the supporting material, are inert than paper and has strongly reactive reagents and used to locate the compound. So then the universal technique involved, that is the iodine vapor. Yes. Also, iodine vapor chamber is there. This is just a small in a plastic box. You can use as the iodine chamber, where a iodine vapor is there, and if you put your TLC within that plastic box, then different spots are very prominently visible, and you recognize the components accordingly. And these are some chromatographic reagents which are used for which are the color forming reagents. So like the reagent used as the color forming reagent, as for amino acid it is D9 isoprene, for ketonaldehyde it is 2,4-dinitrophenylhydrazine. So all these things are there for you as a color forming reagent. Then the same way the retention factor is calculated, the distance traveled by the solute divided by the distance traveled by the solvent, and the RF value depends on the nature of the adsorbent, its chemical nature, particle size, area, and the interaction of the binder. Also its activity, thickness, and uniformity. Nature of the mobile phase, it should be clear, moisture content, precision of mixing in case of mixture and volatility, amount of sample used, vapor pressure equilibrium between the plate and the atmosphere of the development chamber, ambient temperature should be maintained, and this is an example of your thin layer chromatograph. This is your thin layer chromatograph, where this is the origin of the reference line, like your paper chromatography. And whenever we put the samples here, the different components gets detached from this reference line and goes up with the mobile phase. And according to their interaction or adsorption with the stationary phase of the slurry we have made with the silica gel, then your different components gets separated. So this is the mixture we have, and different components we have like A, B, C, and D, E. That means six components are here. Then likewise the RF factor is calculated. Now this is for the data deficit. 6.3 by 8.6. So 8.6 is the total distance traveled by the solvent, and 6.3 is the distance traveled by the component or the solute. Now here it is the factor case 0.7, and it is the plate concept applied to thin layer chromatography. So it is the component we have. Again, this is the line of origin. So this is the total distance traveled by the solvent, that is dm, and ds is the distance traveled by the component. So retention factor will be ds by dm. So here your Tm equal to ds by u. The Tm is defined the distance traveled by the linear velocity, and Tr, it is the solvent doesn't reach the same point until the mobile phase has traveled the distance dm. So this is Tr equal to this, and when you solve the equations one by one, then you finally it will be k dash equal to 1 minus Rf by Rf, where Rf is the retardation or your retention factor. Then one equation is there, that is the number of plate. Sorry, it is the capital N equal to 16 ds by w square, where w is the spot width. Spot width means this one. This is the spot width w, and ds is the distance traveled by the solute. Okay, so this is all about your equation. So what is also this can be calculated. Okay, this here it is not even calculated. Also this can be used for plate height. So this is the plate height n. It is a plate height n equal to this one. And at the end we have the SPPLC, high performance in their chromatography. It is very it has a better resolution and sensitivity like a mass spectrometry, FTIR, and in this technique we have a quality adsorbent, that is your stationary phase, and the particle diameter is 3 to 5 micrometer, and we have 5,000 theoretical plates used as the adsorbent, and it's the same way the slurry is prepared, and your line of origin or reference line is placed, your your sample is placed, and the PLC plate is placed inside your chromatogram in a traditional PLC. But in SPPLC, what happened? The it is much smaller. Typical volume become being 10 to 20 nanoliter with a compact diameter of 1 to 1.5 millimeter. So these dimensions are very less. The number of samples can maybe increase because of compact size. After developing the plate up to a distance of 3 to 6 centimeter, compact separated spots are obtained, which may be have 10 times better detection limit than the conventional case. So here your size of the chromatogram is very less. So that's why the contamination or uh, the contamination is very less, and the distance travel is maximum 3 to 6 centimeter. So your analysis time is very less, and at a time you have a at the same time we have a 10 times better detection limit than the conventional thin layer chromatography we have. Then this is the detection, and for in situ quantitative analysis it is carried out by direct photometric measurement. For the purpose, singular double beam spectrophotometers are available. Scanning densitometer based on Reflectance and absorbance of lights are often used to measure the individual spots. The chromatogram is scanned with a moving beam of light and intensity of reflected light from the plate surface is measured. The difference is light intensity between the PL paper plate without sample and which spot is displayed as peak in the scan. The area of peak corresponds to this. Is now the amount of circle a solute component in the sample. So this is how your in SPCL PLC some spectrophotometers are used with different intensity of lights which are reflected on the surface of the stationary page. So the standard deviation of quantitative determination by densitymeter is greater than 5%. So this is a very advanced modern tool for your separation of components in a mixture. So in the same way, just see here, this is the SPPLC we have for your gallic acid in a triphala using ତ୍ରିଫଳା ଯୋଉଟା ଆମର ତ୍ରିଫଳ ଅଛି ତ୍ରିଫଳା using ethyl acetate and methanol 7:3 ratio in the solvent. The SPPLC was carried out, and we have two spots here. And accordingly, the RF is found to be 0.86. And this is another example of your two-dimensional TLC. This is your sample point. Sample is now separated, and we have the rotation of plate by 90 degree, this one, and final chromatogram is like this. Quantitative aspect of paper chromatography and thin layer chromatography. What is the quantitative aspect? The standards and samples must be applied to the paper or plate in spots of similar size and at similar concentration using flow pipette. All the solvents must be of high purity. While using mixtures, this should be prepared carefully. Development chamber must be brought in equilibrium in the same manner. So after that, we have some physical and chemical method also employed. That is the visual comparison by comparison of spot. So for standards containing known amount and samples must be run on the same sheet of data, and their relative intensity or area will be compared visually. Physical measurement of color spot. The color intensity may be measured by transmission or reflectance using spectrophotometer, scanning photodensitometer, which measures spot intensity, are also available. For organic fluorescent substance, the fluorescent intensity may be measured under illumination with UV radiation. Full spectrum recording and multiple wavelength scanning capability are available commercially. Then spot area measurement, radioactivity measurement, removal of spot. So all these quantitative aspects can be carried out using chromatography method. And then we have a modern PLC from your Camag, Switzerland, the company pioneer in modern equipment of PLC, have come up with a planar chromatography manager with CATS, which offers new approach to PLC. It is a 32-bit Windows software designed to control, monitor, and document all steps of PLC analysis. Camag instrument like the automatic PLC sampler, scanner, etc., can be linked with CAT by means of software interface and offer unique features. That means these are the modern, you can say these are the AI tools, very advanced tools, which are primarily used for the your time bound work of separation using your chromatography technique. But this is some comparison of PC with PLC. So both are considered as the planar chromatography technique, where your plane or flat surfaces are used with similarity, and the reference or the is your retention factor, retardation factor is calculated. Both are widely different in terms of stationary support, developing chamber, detection method, and grain application. So this stationary support for the paper chromatography, it is the paper. It may be filter paper or parchment filter paper of different pore sizes, which is soaked with water generally and with other solvents in other separation of different components. And in PC, what happened? Your chosen solvent is used as the mobile phase, and it may be ascending PC or descending PC. If it is from bottom to top, it is ascending chromatography. If it is from top to bottom, it is descending chromatography. But in PLC, the stationary phase is different because in PLC, on the PLC plate, a slurry is coated uniformly. The slurry is prepared with silica gel and water, a dense liquid, you can say, and that is sprayed by using your chromatographic plate, that is PLC, thin layer chromatography. And the chromatography plates are available in the market with different sizes, starting from 2.5 centimeter into 5 centimeter onwards, and depending on the number of component and the type of component you are trying to separate, your stationary phase accordingly selected, and your PLC is placed inside the chromatogram using suitable solvent at the bottom, and PLC may be regarded as the ascending chromatography. Yes, ascending chromatography because the movement of components is from bottom to top approach. So the differential points in case of PC, cellulose paper acts as the stationary support that is flexible, whereas PLC, the adsorbent material is coated with glass, metal, or plastic sheet which is rigid. In PC, the solvent rises by capillary action, yes, but PLC, the solvent moves similar to that in liquid column chromatography. The development of chromatogram in PC may take several hours, but PLC is much faster as it sorry as it takes only a half an hour or so. So PLC is very fast. PC may be classified as ascending, descending, etc. But PLC is primarily of ascending. Developing chamber used in PC PLC is somewhat different as the paper needs to be hanged with a rod where the plate touches the bottom of the chamber. For quantitative analysis, the paper strip with solute spot needs to be cut with scissor, whereas PLC, the spot portion need to be scrapped. In both the cases, a solute is dissolved through paper, is removed, whereas adsorbent in PLC is filtered out. Paper chromatography takes more time and is less reproducible, whereas PLC is much faster and more reproducible. Paper chromatography and thin layer chromatography both have been carried out using coated liquid phases, and a reversed phase version have been developed. The plate concept has been adapted to PLC, and a high performance TLC has been developed, whereas this is not the case with paper chromatography. The choice of paper in PC is limited, whereas the TSA variety of stationary plates or face surfaces are available. Not many automated instruments have been developed in PC, contrary to thin layer chromatography, whereas automated sampler, capillary dispenser developed in chamber, and documentation system with camera or software have been developed. So both the techniques are two-dimensional techniques, that is paper chromatography as well as thin layer chromatography. So these are very popular techniques or which are very much used by the research students or postgraduate level students in different universities and IITs to separate their different components of their prepared organic samples. Okay, so accordingly, they choose the stationary phase whether to go for paper chromatography or whether to go for your thin layer chromatography. So thin layer chromatography is little expensive than your paper chromatography, and your in the next class we will have the column chromatography discussion, that is in unit 7. Block 2 is completed. We have the block 3. Unit 7 is all about gas chromatography. Yeah. So in the next class we have the gas chromatography. So how your gas solid chromatography and gas liquid chromatography works, what are the different stationary and your mobile phase are used. So we will discuss it, and after that we have unit 8 that is related to HPLC, high performance liquid chromatography, and these are uh, a very advanced techniques which are meshed with your mass spectrometry to carry out different analysis, yeah, at the space, that is in the Mars mission or in the Moon mission. Uh, the HPLC with GCMS are used. Then we have the ion chromatography, ion exchange chromatography at unit 9. It is ion exchanger. Unit 10, it is related to your size exclusion chromatography, where the particles gets separated on the basis of the dimension of size. And we have two different things are there: gel formation and gel filtration chromatography. We'll discuss in the next classes. Then in the last block, we have the membrane chromatography, where osmosis occurs and your different dimensions, different pore sizes of your membrane. That is with efficacy of semi-permeable membrane, your reverse osmosis, dialysis, electrodialysis, and your microfiltration, ultrafiltration, nanofiltration, reverse osmosis. All these things are there in your membrane separation. And at the end, we have the last unit which covers the electrophoresis, that is electromigration of different ions with their respective electrodes. We will have that discussion also. This is electromigration. So for today's class, if anyone is having any doubt related to your paper chromatography or thin layer chromatography, you may ask, or else you wind up the session. This column chromatography, this is a column we have, which is packed with different mesh size of silica gel, and cotton is used at the bottom and top. Okay, here is it, cotton cloth. So cotton is used at the bottom and top, and within or between the column layer, the cotton layer, we have the silica gel with the different mesh size. Then what happens when your mixture is added to your column? Then after that, your solvent is added. Okay, according to the interaction of the solvent with your different components, they are gets separated one by one depending on their interaction with the stationary as well as the mobile phase. You can see here, this is the column, this is the first component we have. So it is the blue color is the solvent. It is separated when the red comes, then third chemical class is under this column. Then it is separated. And continuously your the solvent layer is separated, then your deep blue color it is separated, and accordingly your three components get separated, and further categorization of the NMR, IR, FTIR, in which spectroscopy, these are all can be easily done. This is thin layer chromatography we have. This is all the see here. This is thin layer chromatography. This is the PLC plate, and a slurry of silica gel is just uniformly sprayed, and we have a reference line, a line of origin here. The sample is put at the center of this line, and it is dried, and then it is placed inside the using solvent. Then what happens? The solvent is go up with the different components. So gas chromatography we will discuss tomorrow. So thank you students for your patience hearing, and hopefully we will have in the next three classes we will cover all the units of your MCH-02 course paper with of your PGDC program. So thank you. We will meet again. Thank you.